So today we're going to work on Newton's second law. We're going to end up coming back to the first law and sort of work on them together once you have a good grip on the second law. Newton's second law is also called the law of acceleration. Acceleration is a change in velocity. You want to write that in your notes. That's a definition, a change in velocity. So here's an example. We have a lady, she's walking at 2 meters per second, and she increases her speed to 5 meters per second. That is a change in velocity. She has accelerated. So we're going to do this out, all right? We have a formula for acceleration because we have a formula for everything. Change in velocity divided by time. We need to kind of sort this out, so we're going to use this equation here. A for acceleration is equal to VF, that F stands for final or ending speed, minus VI, your initial or starting speed. So this is your final minus your initial speed. That is your change in velocity. So acceleration is equal to VF minus VI divided by time. How long does it take to make that change? Here's an example. Okay, the lady's at 2 meters per second. It takes her 3 seconds to end up at 5 meters per second. So we plug in our numbers. Remember, VF, your ending speed is first. That's where people usually get stuck. Her ending speed is 5 meters per second minus her starting speed, 2 meters per second, divided by 3 seconds. When we simplify, 5 minus 2 gives us 3 meters per second is her change in speed, divided by 3 seconds is 1 meter per second per second. This is our unit for acceleration. Meters per second, or meters per second squared. Either of those is an acceptable answer. Meters per second alone is not acceptable. Here's an example. We have a roller coaster. All right, it begins the ride at the top of the hill with a velocity of 0 meters per second. Remember, that's your starting speed. It goes in the second spot, 0 meters per second. It takes 3.5 seconds to go down the hill, so that's your time. That goes all the way over here after you've calculated change in speed. After those seconds, it has a velocity of 56 meters per second. So that goes in your ending speed. So we're going to do ending speed minus starting speed. 56 minus 0 is still 56, divided by 3.5. You can punch that into a calculator yourself and get the answer. Here's another example of acceleration. We have a plane, a velocity of 8,000 meters per second north. That's your starting speed, remember. It goes into starting speed, 8,000. 40 seconds later, now this is tricky. Notice that the 40 is written as a word, not as a number. You might miss that if you're not reading carefully. We're going to plug 40 seconds into the time spot. It passes over point B with a velocity of 10,000 meters per second. So, ending speed, 10,000 meters. This one we have to do some math to get the change in speed. 10,000 meters minus 8,000 meters gives you 2,000 meters. Divided by 40 seconds, that's going to be, you do the math and plug in your answer. Remember, if you need calculators, they're at the front of the room in the yellow caddy. All right, so now that we can calculate acceleration using your starting and ending speeds, we need to know Newton's second law. Acceleration is produced when a force acts on a mass. Here are those words again, force. All right, that's going to be the central word in Newton's laws that we're concerned with. Now, we can break this law down into two parts. See, we take a little short sentence like that and we make lots of long sentences out of it. Go figures. Science, right? So acceleration depends on mass, and you instinctively know this. When you're thinking about this, remember back to our straw rockets, the big rocket versus the small rocket and how it behaved on that launcher. The greater the mass of the object being accelerated, the greater the amount of force is needed to accelerate the object, right? The heavier rocket, it took a bigger number on the plunger to make the rocket go. If you would rather write something a little shorter and simpler, you can just say more mass requires more force. Same thing, more succinct. Okay, the other part of this law is that acceleration depends on force. The greater the amount of force applied to the object, the greater amount of acceleration will be produced. That's kind of like a no-brainer. You guys know this stuff already. More force means more acceleration. All that's saying is that the harder you push something, the faster it's going to go, right? I bet you would agree with that. Again, the higher the number on the launcher that you picked with the straw rockets, the farther your rocket would go. Some of you, I know, spent your time all in the top range of the launcher because you liked when it went far. All right, now, Newton's second law we can do math with. This is a very mathy kind of law, so we're going to see a lot of math here. Expressed using math, it would be F equals ma. That one's pretty famous. All right, force equals mass times acceleration. You will need all three of these formulae. Okay, notice that we have a formula rearranged from F equals ma to find both the mass and the acceleration when you're given one of them. All right, let's do a practice problem. Blah, 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 blah. What force is he applying to the box? We want force for an answer. We want F equals ma as the formula we're going to choose. So we're going to use F equals ma, and you can amuse yourself while I write like a kindergartner here, all right? So the mass of the box is 5 kilograms, kindergarten math, times the acceleration of the box, 1 meter per second squared. All right, it's going to be equal to the force that he applies, 5 times 1, math skills tells us that's 5, and remember the unit of force is newtons. All right, named for the guy with the law. All right, now we're looking at this next one. What is the baseball's acceleration? For this one, we want the formula force divided by mass. So we're going to plug our numbers in. The force that he threw with is 9 newtons. The baseball has a mass of 0.5 kilograms. Kindergarten writing. All right, that looks a little better. All right, so now we're going to put this into our calculator. We're going to find, because we're dividing by a decimal, that the answer is actually larger than the original numbers. And the baseball has an acceleration of 18 meters per second squared, or meters per second if you prefer. All right, see how we're plugging that in? Be sure to do the math. Don't just start randomly doing things. Finally, the question is asking, what is the mass? So we're going to use the formula. Mass equals force divided by acceleration. So we're going to plug it in. She pushes with a force of 80 newtons because she's strong. 80 newtons divided by the acceleration, which is 2 meters per second squared. All right, when we do the math out, we realize that the mass of her sister is 40 kilograms. Considering there's 2.2 pounds per kilogram, her sister actually weighs 88 pounds, so her sister's probably not that little. All right, maybe she's in, 5th grade or something. All right, so those are your examples. You now are going to do the rest of the practice problems on your paper. When you finish the practice problems, keep your notes for me to see tomorrow, and you're going to go ask the sub for the practice problems on the different paper and work on those. Depending on how confident you feel about this, you are either going to ask for one without the scaffold, okay, this fill-in-the-blank scaffold here to help you plug your numbers in. I have copies with the scaffold and without the scaffold, depending on how you feel about it, all right? So I want everyone to practice with what's going to make them feel comfortable. When I get back, we're going to start doing some stuff with Newton's first and second laws that's going to be more exciting than just taking notes, but you might as well get it over and done with, and we'll move on, all right? Great job today, guys. Thank you.